Welcome back. Before we start our deep dive into today's topic, please take a second to hit that like button, subscribe to the channel and turn on notifications so you never miss a technical breakdown. It really helps the channel grow. Welcome to our deep dive into Apache Madlib. In today's tutorial, we'll explore how this powerful open source library brings machine learning capabilities directly into your database environment. Unlike traditional tools that require moving data out of databases for analysis, Madlib performs computations where the data lives, dramatically improving performance and simplifying workflows. Apache Madlib is an open-source library designed to bring machine learning and data mining capabilities directly into relational databases. It extends PostgreSQL and Greenplum, enabling users to perform complex analytics using familiar SQL syntax. This approach allows scalable and efficient machine learning without the overhead of data transfer. Why choose Madlib over traditional machine learning tools? The main advantage lies in its in-database execution model. Since data never leaves the database, processing is faster and more secure. Additionally, analysts who already know SQL can quickly adopt Madlib, reducing the learning curve and eliminating the need for complex ETL pipelines. Madlib's architecture is designed to integrate seamlessly with PostgreSQL and Greenplum. It adds user-defined functions, UDFs, that allow complex machine learning algorithms to be executed within the database engine itself. This design ensures that large datasets can be processed in parallel, making Madlib highly scalable. Madlib supports a wide range of machine learning algorithms, including regression models, classification trees, clustering techniques, and even advanced graph analytics. Whether you're performing predictive modeling or exploring data patterns, Madlib has the tools to help you succeed. Getting started with Madlib is straightforward. First, ensure you have PostgreSQL or Greenplum installed. Then, install Madlib as an extension to your database. Once configured, you can begin running Madlib functions using standard SQL queries. We recommend testing with sample datasets to verify everything is working correctly. Let's walk through a simple example using linear regression. In Madlib, you can train a model using the linreg_train function, specifying your feature and target columns. Once trained, the model coefficients are stored in a table, and you can make predictions using linreg_predict. This process keeps everything within the database, ensuring speed and efficiency. Logistic regression is another commonly used algorithm in Madlib. You start by training the model with logreg_train, which outputs model coefficients and evaluation metrics. These metrics help you assess model performance, and you can use the trained model to predict outcomes for new data, all within SQL. Madlib also supports decision trees and random forests, which are powerful tools for classification tasks. You can train a decision tree using dt_train, and Madlib will generate a tree structure you can interpret. Random forests combine multiple trees to improve accuracy, and Madlib handles both categorical and numerical features seamlessly. Clustering is a great way to discover hidden patterns in your data. Madlib's k-means implementation uses the k-means ++ algorithm for smart initialization, ensuring faster convergence. You can cluster large datasets efficiently and visualize the results directly within the database using Madlib's built-in tools. Association rule mining helps uncover relationships between items in datasets, such as products frequently bought together. Madlib implements the a priori algorithm to find frequent item sets and generate association rules. This technique is widely used in market basket analysis to inform business strategies. Graph analytics is another powerful feature of Madlib. You can analyze social networks, web graphs, and more using algorithms like PageRank and shortest path. These tools help you understand relationships and influence within your data, and Madlib ensures scalable processing even for large graphs. For time series data, Madlib offers ARIMA models to forecast future values. These models can handle seasonality, trends, and noise in your data, providing robust predictions. Madlib also includes smoothing techniques to refine your forecasts and improve accuracy. To get the most out of Madlib, consider these performance tips. Use indexing to speed up queries, partition large datasets for better manageability, and take advantage of MADlib's parallel execution capabilities. Monitoring resource usage during training can also help you optimize performance further. Security is a key advantage of MADlib. Since all processing happens within the database, there's no risk of data exposure during transfer. You can also implement role-based access control and maintain audit logs to track usage, ensuring compliance and data integrity. Let's look at a real-world use case: fraud detection in financial transactions. MADlib can train models on historical fraud data and score new transactions in real time. By tuning models to reduce false positives, financial institutions can protect customers while minimizing disruptions. How does MADlib compare with other machine learning tools? Unlike Scikit-learn or R, MADlib operates directly in the database, eliminating data movement. Compared to Spark MLib, it uses SQL instead of Scala or Python. Choose MADlib if your infrastructure is database-centric and your team prefers SQL. MADlib benefits from an active open-source community. You'll find comprehensive documentation, tutorials, and sample datasets to help you get started. If you're interested in contributing, the project welcomes enhancements and bug fixes on GitHub. While MADlib offers many benefits, it also has limitations. It's restricted to PostgreSQL and Greenplum environments, and the algorithm library is smaller than Python-based tools. Additionally, mastering MADlib requires strong SQL skills, and the community is smaller than that of mainstream ML libraries. MADlib is ideal when you have large datasets stored in PostgreSQL or Greenplum and need high performance, secure analytics without data movement. If your team prefers SQL over Python and prioritizes performance, MADlib is a strong choice. For beginners, start by mastering SQL and understanding database concepts. Then, install MADlib and experiment with sample queries. Begin with basic statistical functions before moving on to machine learning algorithms and model tuning. Let's walk through a sample dataset included with MADlib. You can run descriptive statistics to understand the data, train a simple regression model, and evaluate its performance, all using SQL commands within your database environment. Evaluating your models is crucial. MADlib provides metrics like R² for regression and accuracy, or F1 score for classification. You can also generate confusion matrices for deeper insights and use cross-validation to ensure your model's robustness. Feature engineering is key to successful machine learning. With MADlib, you can create derived features using SQL, handle missing data and outliers, and normalize or scale features. For time series data, window functions in SQL can help extract meaningful features. Once trained, MADlib models are stored in database tables and can be used for predictions via SQL functions. You can integrate these models with BI tools that support SQL and monitor performance over time to ensure continued accuracy. If you encounter issues, start by checking MADlib installation logs and verifying database permissions. Ensure your system has sufficient memory and carefully review your SQL syntax for any errors. These steps will resolve most common problems. To succeed with MADlib, start with small datasets for testing. Use indexing to boost performance, document your models and workflows, and keep MADlib updated to benefit from the latest features and fixes. In this case study, we'll predict customer churn using logistic regression. By training on historical customer data, we can predict the probability of churn for each user and implement targeted retention strategies to reduce attrition. Another powerful use case is predictive maintenance. By analyzing sensor data for anomalies and training models on historical equipment failures, you can predict when maintenance is needed, reducing downtime and operational costs. Compared to traditional analytics tools, MADlib eliminates data movement overhead, processes data faster within database execution, simplifies data pipelines, and reduces infrastructure complexity. These advantages make it ideal for modern data-driven organizations. The future of in-database analytics looks promising, with growing demand for real-time insights, integration with cloud databases, expansion of supported algorithms, and enhanced automation. MADlib is well positioned to evolve with these trends. Ready to get started? Begin by installing PostgreSQL or Greenplum, then download and install MADlib. Run sample queries to verify your setup and explore the documentation and tutorials to deepen your understanding. Now it's your turn. Choose a dataset and problem, prepare your data using SQL queries, train a model with MADlib functions, and evaluate the results. This hands-on exercise will solidify your understanding of MADlib. Performance benchmarks show that MADlib outperforms traditional Python libraries on large datasets due to in-database execution and parallel processing. It reduces latency and scales efficiently, making it ideal for enterprise use cases. Users report significant improvements after adopting MADlib. Processing times for analytics have dropped, data pipelines are simpler, model accuracy has improved, and teams are more productive thanks to the streamlined workflow. In summary, MADlib brings powerful machine learning capabilities directly into your database. It supports a wide range of algorithms, is ideal for PostgreSQL and Greenplum users, and significantly improves performance and security by eliminating data movement. Thanks for joining us on this journey through Apache Madlib. If you found this tutorial helpful, please like, subscribe, and share it with your data team. Don't forget to comment below with your use cases or questions. We'd love to hear from you. And that wraps up our explanation. If you found this useful, please hit the like button and share it with a fellow developer. Don't forget to subscribe for more technical tutorials. Thanks for watching, and I'll see you in the next one.